Hi everyone, welcome to week 5. This is the first topic for week 5. So this week we're going to be talking about two general topics that relate to the field of epidemiology, and both of them are major study designs. The first, which we'll be talking about in this lesson, is we're going to be focused on a type of study design called cohort studies. And then the next topic and the last topic for this week, we're going to be talking about another type called case-controlled study designs. So what are the learning objectives for this lesson? Well, we're going to talk about the different types of cohort studies. And by the way, the reason why I chose a picture of babies for this cover slide is because a lot of times a very popular type of cohort study is called a birth study or a birth cohort study, where they will, researchers will follow all of the individuals that were born during a specific year or period of years and follow them over time. But there's many different types of cohort studies, and we're going to talk about just a few of them in this course. So we're going to talk about the different types of cohort studies. There are two designs that we're going to focus on specifically in this course. There's other types, there's many complicated types, but this is an intro course, so we're just going to focus on retrospective and prospective cohort study designs. Then, of course, we're going to go and spend some time talking about, what are the features of different cohort studies. So how do we choose exposed individuals versus unexposed individuals? How do we define different variables? Where do we find the information that we're looking for? Etc. And then we're going to talk about some of the strengths and the limitations of these types of study designs. So just to kind of get you reoriented where we are. So last week, but the last series of lessons we did, which was all the way back on week 3, when we did the overview of study designs, we actually talked about all of these, except the ones that are crossed out in red. But the only lesson that I did on the descriptive studies, the case reports, case series, ecological studies, and the cross-sectional studies was just that intro to lesson where we went over all the different study designs. And the reason for that, as I've written on the course page and kind of alluded to, is that descriptive studies, case report, case series, cross-sectional, ecological studies, they're relatively simplistic study designs. They don't require a lot of time to talk about and discuss. And because they're simple, unfortunately, there are a lot of drawbacks to them when interpreting the data. And one of the biggest things that's missing when you're looking for a really good study design is that they don't have what we call a comparison group. So observational studies, the two that we're going to talk about that fall into that category, are cohort and case control studies. We'll talk about cohort today, case control in the next lesson. And both of these study designs have an advantage over the descriptive study designs in that they have what we call a comparison group, or a group to compare to. And that's important for a lot of different reasons. So we'll talk about experimental studies next week, but this week we'll focus on cohort and case control studies. Okay, so on this slide I've got, there are two diagrams that are pictured, as you can see. The one on the left right here is actually from another epidemiology textbook, so you don't have access to this in your textbook. The one that you have is, of course, you should be familiar with. It's the one right here on the right. Okay, these two diagrams are essentially saying the exact same thing. I just tend to like the diagrams that are used in the other textbook a little bit better, because I think that they give a better visual and help the reader to understand what's going on in the actual study design. So I just didn't want to give you this diagram on the left and you're like, I don't know what that is. So it's the same thing that's being presented in this figure on the right, which you should recognize from your textbook. It's basically giving a schematic visual overview of how cohort studies are designed and how where the investigator is actually going to define the cohorts, or define the different groups, and then where they're going to actually measure the outcomes. So taking a look at this one on the left, okay, what's happening here, you have a source population. So we're going to say that we're interested in understanding whether or not a group of individuals, let's look at NC Wesleyan students. When NC Wesleyan students come in, we're just going to say, I don't know if this is true or not, but we're just going to make this up. We're going to say that all students are given the opportunity to take an optional STD sexual health prevention course. They don't have to take it, but they can. Okay? So say we're interested in understanding whether or not students are take that course or not has an impact on their risk of contracting an STD, say during their freshman year. Okay, so they have the option to take the course when they're freshmen, right when they come in their freshman year, but they're not they don't have to take it, but they can. And then we're interested to know, okay, well, during the freshman year, does taking that class help to prevent or reduce the risk of contracting an STD? So the source population that we would be looking at would be all incoming freshmen NC Wesleyan students, okay? And we would say, okay, those individuals that are exposed, let's just say that the exposed group would be those individuals that took the class, those individuals that decided, those freshmen that came in that said, yes, I want to take this class. We would then select a comparison group, which would be those individuals that, say, incoming freshmen, but they did not take the class. And then what we would do is, over the course of the next 9 months, the next, academic 2 semesters, the fall semester and the spring semester, we would measure through various ways what students contracted an STD and which did not. And then we would say, okay, of those individuals that took the group or took the class, how many of those individuals developed an STD? And of those students that did not take it, how many of those individuals developed an STD? So that's essentially what a cohort study is. It's selecting your groups from a source population based on their exposure status. Many times cohort studies are interested in looking at exposure to smoking or exposure to an environmental hazard. There's lots of things that you can look at. Okay? And then what they're going to do is they will follow those individuals over time, and they will measure whether or not those individuals develop the outcome of question incidents. So new cases, whatever that outcome is. So we should pause and, I guess, define what a cohort is. It's a term that is used a lot, and some people may not know exactly what a cohort is. So let's take a moment and just define what we mean when we're talking about a cohort. And there's 2 definitions here, and both of them actually apply. First is any designated group of persons who are followed or traced over a period of time. And essentially that's what a cohort is in a cohort research study. It's we are selecting a group of people, we're enrolling them in this study, this research study, and then we're following those individuals over time. Okay? The number of individuals that we enroll in this cohort and the length of time that we follow them, varies from study to study, just depending on how many people we need in this study to actually effectively study what we're hoping to find. How many resources we have, and then also, how long we follow them is going to depend on resources as well and what it is that we're trying to measure. So a cohort is also defined as a group of individuals with the common characteristics or experience. And for cohort epidemiological research studies, that's usually how you're defining your cohort, is by some characteristic or experience. And in many cases, we call this common exposure. So what is the exposure that you're wanting to look at? Is it how much they smoke? Is it how much, whether or not this individual, lived in a certain community during a certain period of time? So that common characteristics is what's going to bind that group of people. Okay, so now let's talk about the study variables that are part of a cohort study. So the first thing that you're going to want to measure is your exposure variables. So these are the things that you're interested, the risk factors essentially that you're looking to measure. What kind of risk factor might you be looking to assess? In the NC Wesleyan example that I just went over, the exposure variable would be whether or not that student elected to take that sexual health course, or they didn't. So the exposure would either be yes, they took it, or no, they didn't. And they call that a dichotomous category. When you're either given, there's a very clear line as to whether the person was exposed or not exposed. So in this case, did the student take the class or did they not, right? That's called a dichotomous category. It's either yes or no, right? Sometimes you may have exposed or unexposed. But it's easy to see, that a dichotomous category is kind of a no-duh when you're thinking about, did the student take the class or did the student not take the class? But for many of the variables that we're going to study in epidemiology, there's not that clear line of yes or no, or exposed or unexposed, right? So for many studies, the researchers may decide to have to basically create these arbitrary limits that this is what we're going to say is exposed and this is what we're going to say is not exposed. However, the general rule of thumb is that whenever possible, whenever you as a researcher are able to access the full data, meaning you're able to access a continuous data set where you are able to actually get a hold of the raw data. So for example, instead of, say for example, you are looking at measuring smoking exposure, right? And say the only data that you can access, they have categorized it into two groups, either low smoker or high smoker, right? Well, you'd prefer to have the number of cigarettes that each of those individuals smoked per day, if possible, right? So without going into too much detail, if you've taken statistics before, you'll have a better understanding of this. But essentially, the more data, the more variability in your data that you can have, the better off that you'll be. So you don't want to do this dichotomous variable unless you absolutely have to. So then the underlying statement says, in general, when doing research, you want to use as much detail as you can. But sometimes this is all you have access to, or you may not have the statistical software to do the different types of analyses that you want when you have continuous data. So this may be what you're limited to. But if possible, you want to make sure, or you want to try and access as much information as you can, and not have things already grouped into categories for you. Sometimes you may read a research study where instead of doing the dichotomous yes, no, or exposed, not exposed, you may have groups classified into different levels of exposure, low exposure, medium, high. This is actually preferred because it can allow you to, investigators to assess what we call a dose-response relationship, meaning as the dose of exposure increases, does the risk also increase? So statistically speaking, it's better to have more information or more categories than to limit them to just the dichotomous yes, no. Okay, sorry, my slides are jumping around a little bit. Okay, so we just talked about exposure variables. Well, the other thing we have to measure is our outcome, right? So we're going to follow this group of people over a specified period of time, and then we're going to look for and try to measure whatever outcome that we're interested in. So this might be, lung cancer. It might be development of an STD, whatever it may be. There's a wide variety. So basically, we follow those groups, and then the outcomes of interest. So on that note, there are lots of different things that can be measured. It may be a precursor of disease. So like many times, researchers may want to measure the development of what we call pre-diabetes, because it takes a long time for a person to actually develop full-blown diabetes. So there's a state called, or a condition, medical condition called pre-diabetes. That may be something that they want to measure. It could be seeing if an individual develops hypertension, which is high blood pressure, which is a precursor for many other chronic diseases. They may want to measure the first occurrence of the disease, or they may actually measure the disease itself that they're looking to investigate. Death is also another option as well, so measuring mortality rates, which we've already kind of talked about this before in a previous lecture. And the length of follow-up can range from a few hours for some infectious diseases, to see rate of transmission, or several decades. And there are many studies that they talk about in your textbook that give you some examples of long-term chronic diseases. So let's talk a little bit about the types of cohort studies, and we're just going to focus really on two main types for this course. There are more types, subtypes of cohort studies than the ones we'll talk about, but for an intro course, these are the two that we're going to focus on. So the first type of cohort study that we're going to talk about are called prospective cohort studies. So this visual is to help you kind of understand where the study is actually happening and the natural course of the disease. So for a prospective cohort study, it's just like it sounds. You're going to be following individuals forward in time. Nothing has happened. The exposure has happened, but the disease or the outcome has not actually happened yet. So an example of this might be you enroll in all the individuals in a certain community, right, into this study. And you classify them as either smokers or non-smokers. So at the start of the study, you can measure, are these individuals exposed or are they not exposed? So all the members of the community are enrolled in the study. And then you ask each participant at the start of the study, do you smoke, do you not smoke, right? Then you follow these same individuals over a length of time, let's just say 10 years, right? And then you measure whatever your outcome is. It could be a precursor of a disease, like the development of hypertension, or it could be the disease itself, like diagnosis of diabetes, whatever, right? So prospective cohort study, at the time that you're starting to measure study participants, only the exposure has occurred, not the outcome. There's also a type of cohort study called a retrospective study, and it's exactly like it would sound. It's the opposite of a prospective study. So this would occur when, at the point in time that the researchers start the study, both the exposure and the disease have occurred at the time that the researchers are beginning to measure. Okay? But it's documented, the data that they are going to use to basically study their research question, they are documented in order. They have data source where they know that the exposure has occurred before the disease. So we talked about it in a cross-sectional study. We take a group of people and we measure the exposure and the outcome simultaneously. So it becomes really difficult to understand whether or not the exposure actually happened before the development of the disease. So it makes it very difficult to determine what we call temporality, right, which is very important. So with a retrospective cohort study, even though by the time that the researchers are doing the actual data collection and evaluation and statistical evaluation, both things have happened already, they have data that clearly documents that the exposure has occurred before the development of the disease. Okay, so that's the key difference with that. So how do you choose which type of study? Well, of course, it depends on a lot of different things, what your research question is. And you guys will have some opportunities to practice thinking about this in your practice questions for this week, okay? So these are just kind of general, this is what you should think about, but hopefully through the practice exercises, you'll be able to actually kind of apply and understand as they relate to specific examples. So what is your research question? Of course, practical restraints. How much time and money do you have? As I alluded to earlier, following a group of people over a long period of time is very, very time expensive. It's very resource expensive. So what kind of data do you have available? Do you already have a database that you could use data from that would answer your question, or do you have to do a new study? And then, of course, considering the advantages and disadvantages of the two different prospective and retrospective study designs, which we'll recap in just a minute. So, what are some of the pros of a retrospective cohort study? Well, it's many times over more efficient. Because typically what you're doing is, as a researcher, you're coming in and saying, okay, I have access to all of these data, all of this data that's in this data set, and I'm not having to collect it, I'm just kind of doing the analysis. The con is that while it's great when you can find it, finding that information can be really challenging. Or you might have one piece of the puzzle that you need. Say, for example, you know the exposures, or no, you know the outcome. Say you know that all of these individuals at a certain hospital, you pull hospital records, and you know all of these individuals died of lung cancer, right? But you may not have information on exposure that you need. So are you able to go back and collect that information? How could you get that information? Are there other ways to get at that information? So you may have one, but not the other. Some cons of prospective cohort studies are that they're less efficient. As I said, following a group of people for a long period of time is expensive. The pros are that you're able to collect the information that you need. You can make sure that you get all the information that you need. Of course, it's going to cost you money, time, resources, etc. But the big pro to those prospective cohort studies is that you can decide what variables that you want to collect and collect them all the way through. Okay, so some things to think about. All right, so some things to think about when you're designing any type of cohort study. So what this is saying, it says, although random assignment RA is simply not possible with a cohort study as it is with an experimental study, design cohort studies try to emulate several of the key characteristics of random assignment to help reduce potential bias in study design. So if you've never heard of random assignment, we will talk about it extensively and why it's incredibly beneficial when we talk about experimental study designs next week. This is one of those issues that I've talked about earlier, that teaching epidemiology, it's hard to go through topics in a chronological order because it requires that you have an understanding of some other topics. So this is one of those examples where we're talking about a topic that we're not going to talk about until next week. So just kind of put a hold on that. But random assignment is essentially assigning research participants to one group or another completely by chance. So whether or not an individual goes to one study treatment or another it basically comes down completely to chance. They have no control over it, or the roll of a dice, okay? So there's lots of advantages to that, and we'll talk about that next week. But some ways that cohort studies, because they're not randomizing participants, remember we're defining people whether they've experienced the exposure or not experienced the exposure. That's not random assignment, right? There's other things that are associated with those exposures or not exposed that could potentially be problematic when interpreting the results of your study. And so that'll come in when we talk about later chapters, confounding and bias. So things that you can do if you're doing a cohort study to help kind of mimic that random assignment is that you can try to minimize the differences between groups by selecting them to be as similar as possible. You can blind study staff to subjects, and that can be important because if an individual, if your research staff who's collecting data know that an individual has been exposed or not exposed, they may ask questions or collect data in a way that could bias your results. And then the last one is about statistical power, and you can just kind of put a hold on that bullet point for right now until we get into research and experimental designs. I'm just realizing this was a slide that I had meant to take out, so you can just disregard this information. Sorry about that, guys. So in summary, this is a chart from another textbook that I think does a good job of just kind of presenting some of the pros and cons of this type of study. So strengths, it's very good for rare exposures because you can select people based on their exposure. It's less vulnerable to bias, meaning you're following people forward. You can measure disease incidence or risk directly, and you've got that kind of clear temporal relationship with the prospective study. Some of the weaknesses is that if it's a rare outcome, like we talked about, we'll talk about next week. If it's a rare outcome, if it's something that occurs does not occur very often, like pancreatic cancer or gallbladder cancer, I think, you may have to follow a lot of people for a very long period of time to even see a few cases develop, and that's not very efficient. So they can be very expensive and time-consuming studies to do. They're inefficient for diseases with a long incubation and latent period, meaning if it takes a disease a long time to develop, like cancer, it can be very expensive to follow people long enough to see that outcome developed. Okay, and then of course the retrospective, even though you, in theory, have data that show that there's that temporal relationship, there can be problems sometimes, or you need to at least be aware of or thinking about whether or not your data are biased and whether or not you really can establish through the data that you have that there are, that temporal relationship has been established through the way the data are collected. Okay, so that's cohort studies. The next lesson we'll talk about case control studies.